Hello everyone, welcome back to my YouTube channel. So in this video, let us discuss about Module 5 of electric circuit analysis, that is unbalanced three-phase circuits. Unbalanced circuits, three-phase circuits. So you can refer the syllabus. Before that, let me clarify you. Before knowing about the Module 5A, you should know about some basics. Like you should know what is phase sequence, and what is balanced supply, what is unbalanced supply, what is balanced load, what is unbalanced load. So you need to know these things. One is supply, balanced supply. Before that, you should know what is three-phase supply, three-phase supply. So three-phase supply means it is having three voltages with the same magnitude and sorry, or else different magnitude. The voltages which have same magnitude but the phase difference is 120-degree apart, then you can call that as three-phase supply. If three voltages, line voltages or phase voltages, whatever. Suppose we can consider line voltages VRY, VYB, VBR, or else VRB. If all the three voltages are having a phase difference of 120-degree, then you can call that as three-phase supply. Balanced supply. If all the three phase voltages, either line voltage or phase voltage, line current or phase current, if it is having the same magnitude but the phase difference is 120-degree apart, then you can call that as balanced supply. All the three voltages are having same magnitude but the phase difference is 120-degree apart. Okay. So unbalanced means if any one condition which fails means, then you can call that as unbalanced supply. Similarly, balanced load, unbalanced load. If all the three loads are having the same value, then you can call that as balanced load. If any one of the load which fails to maintain a same value, then you can call that as unbalanced load. Sequence, phase sequence. Three phase voltages are having three different phases like R, Y, B. Sometimes they can call the sequences as A, B, C also. This is called sequence. There are two sequences you can get. One is three types of sequence. One is positive phase sequence, negative phase sequence, zero phase sequence. In case of zero phase sequence, the circuit which will be behaves as a pure resistive circuit. Positive phase sequence is nothing but if the sequence is having R to Y, Y to B, if the sequences are in clockwise direction, if the sequences are in clockwise direction with a phase difference of 120-degree apart is called as positive phase sequence. And one more we have, that is negative phase sequence. So negative phase sequence means if the sequences are opposite together, if the sequences are opposite but the phase difference is 120-degree, then you can call that as negative phase sequence. For example, if the sequence is in clockwise direction, then you can call that as positive phase sequence. And if the sequences are in anti-clockwise direction, in this direction, this is called negative phase sequence. In this case, the sequence is R to Y, or else RYB, you are writing like this. You need to read the sequence in anti-clockwise. So that here the sequence is RBY, negative phase sequence. There are two phase sequences, one is RBY and one more is RYB. Sometimes you can rename the, sometimes you are writing in the form of ABC also. ABC is a positive phase sequence. Similarly, ACB is a negative phase sequence. Different types or else uh, different way of writing the phase sequences. ABC is the same as BCA is same as CAB. Similarly, ACB is the same as CBA and BAC. If you're having RBY and RYB, RBY is same as BYR, YRB. Similarly, RYB is same as YBR, BRY. You'll understand why I'm writing this, because you just take a screenshot while solving the problem. You need to know the phase sequence and the references. So this is about the phase sequence. Next, we'll discuss about references. So references is nothing but, you know that the references, you can either can take voltage as a reference or current as a reference, but it is depending on the type of connection. You know that there are two types of connection. One is a star connection, other one is a delta connection. So star connection and delta connection. Star connection means all the three phases are connected together to form a junction is called neutral. And delta connected means one end of phase is connected to the another starting point of the phase together to form delta. You can see star. This is a star connection. This is your star connection, just for your reference. This is R, Y, B. So if the sequence is RBY, you can see RBY. This is RBY sequence. Suppose if you're writing R by B, then you will be writing R by B like this. Okay. Yeah, I will discuss that later. So if all the phases are having same load, then you can call it as balanced load. If it is having different loads like this, ZR, ZB, ZY, unbalanced load. Okay. And it is having two voltages. One is a line voltage, other one is a phase voltage. Line voltage is nothing but voltage between these two lines. That is VRY, VYB, and VBR. These are line voltages. And phase voltage it is having VR, VY, VB. And condition for star connected network is line current is the same as a phase current. That is nothing but IR is same as IY is same as IB if the supply is balanced. Similarly, line voltage is same as root 3 times of phase voltage. Therefore, line voltages are VR, VY, VB. And phase voltages are, sorry, these are the phase voltages. And line voltages are VRY, VYB, VBR. These are line voltages. So based on this, you are writing the phasor diagram. How will you draw the phasor diagram? If you are considering the line voltages, all the three line voltages are having the same magnitude, but the phase difference is 120 degree apart. So in this case, if the sequence is RYB, you can see the three different line voltages VRY, VYB, VBR. If the sequence is R by B, you can take any one voltage as a reference. You can take VRY as a reference. So whatever the value of voltage, whatever the value of reference you are taking, the angle of the reference is always zero. That you already know the basics. So that I'm considering VRY as a reference. Sequence is R by B means you need to write in a clockwise direction. The line voltages you need to write in clockwise direction. VRY, the next line voltage is VYB in a clockwise direction, and the next is VBR in a clockwise direction. And the phase difference is always 120 degree. Then you need to write the values of voltages. So how we are writing VRY, it is a reference. So that magnitude of VRY at an angle of 0 degree. And the phasor direction is anti-clockwise. So that VYB lags VRY at an angle of minus 120 degree. Similarly, VBR lags VRY at an angle of minus 240, or else VBR leads VRY at an angle of plus 120 degree. These are the voltage values. Like that you have tried. If the sequence is VRY, like that the sequence will change. Sorry, if the reference is VRY, like that the references will change. Sometimes they will give you VYB as a reference. Instead of RYB, they can give you ABC. Okay. VYB is a reference means VYB at an angle of 0 degree. If the phase sequence is RYB, this will be VBR and this will be VRY. I hope you're getting this. Okay. So like this, you need to understand. So just for your reference, what you have to do now. So I will just brief about the sequences, like how we can able to write. if the sequence is clockwise, sorry, if the sequence, I will write it here, sequence is RYB and the reference is VRY. Sometimes they will give you in the form of ABC also. If the sequence is ABC and the reference is VAB, in that case you need to write the phasor diagram. How we are writing? The reference is VAB. So that this is the reference VAB. Sequence is ABC means you need to write the sequence in the form of clockwise. VAB, the next to the VAB is VBC, then VCA. All the three voltages are having 120-degree phase differences. Then how we are writing the values of voltages? The voltages you are writing now, this is VAB at an angle of 0 degree. The reference is VAB. VBC at an angle of minus 120 degree because VBC lags VAB at an angle of 120 degree. Similarly, VCA at an angle of plus 120 degree or minus 240 degree. For the same case, if the sequence is ABC but reference is VCA, in that case again the same thing, the references you should start VCA here. This is VCA. Next, the sequence is ABC means clockwise you need to write the line voltages. So after VCA, VAB, then again VBC. The value of the phase difference is 120 degree. So that you're writing here VCA at an angle of 0 degree, VAB at an angle of minus 120 degree, VBC at an angle of plus 120 degree or minus 240 degree, both are same. The sequence is RYB or ABC. Suppose if the sequence is changing, so I'll just compare this. Okay, suppose if the sequence is RBY, or ACB and reference is VAC. In that case, you start to write the line voltages in anti-clockwise. So how we are writing? VAC or VCA, both are same. VAC, negative sequence, ACB means. So after VAC, here you need to write VCB, then here you need to write VBA. This is at an angle of 0 degree, at an angle of minus 120 degree, at an angle of plus 120 degree. Same as if the sequence is ACB and the reference is VBC. CB is same as BC, don't mind. So you need to write VBC is a sequence. In clockwise, you need to write the line voltage VBC, VCA, VAB. Then you are writing the values VBC at an angle of 0 degree, VAB at an angle of minus 120 degree, VCA at an angle of plus 120 degree. So this is about the phase sequence. I am not dragging much. You just understand this because you will get to know while solving the problems. The phase sequence and the references is very important before solving the problem. I hope you are getting the concept. If you are having any doubts regarding this, feel free to write in the comment box. And if you really like this video, do share maximum and inform your friends to subscribe the channel too. Thank you so much. Have a nice day.